Hello everyone, my name is Ashwin Shirsat and I'm currently a third year PhD student at North Carolina State University. Today, I will be presenting our research titled Hierarchical Multi-timescale Framework for the Operation of Dynamic Community Microgrid. Due to the changing climatic conditions and cause of global warming, the electric grid is facing increasing threats from extreme weather events along with a man-made events such as cybersecurity attacks. These events are capable of taking down the entire grid for a really long duration. So in this kind of a period, how do we try to help these electric grids sustain such a kind of disasters and try to prolong the supply even when the main grid is down? So in order to do this, microgrids have been proven to be one of the key resources for enhancing the grid resiliency. In our research, we developed a new three-stage hierarchical multi-timescale framework for the energy management of microgrids under such extreme conditions, wherein the upstream network support has been cut off due to extreme events for a really long period of time. The unique features of our approach are going to be proactive load scheduling, the system is robust to forecast errors, optimal resource allocation, a scheduled load curtailment, and our capability to sustain operation for long durations. So to get down to the methodology, our basic idea is that the forecast error reduces as and when the time scale moves closer to the actual time of dispatch. And if we make sequential updates to the schedule using new forecasts at a newer time scale, we can result in a proactive scheduling. So for doing this, we have a three-stage approach wherein each stage, starting from stage 1 to stage 3, moves closer and closer to the actual time of dispatch. The time granularity of each stage goes on reducing because now we have much more better forecasts, as well as the number of constraints in each of the stages also go on reducing in order to make sure that each stage is computationally efficient given the amount of time that is required and available for close to the dispatch of the results of a particular stage. To demonstrate the results of our three-stage approach, we perform a case study on IEEE 123 bus network. We also introduce a new feature called the dynamic boundary, wherein the microgrid can expand its reach to the neighboring nodes of the distribution grid in order to provide supply to the neighboring nodes, as well as to take some help from the neighboring load resources in order to increase the duration for which the network can be sustained. We divide the 123 bus system into 3 zones, wherein the zone 1 is basically the microgrid, and zone 2 and 3 are the surrounding areas into which the microgrid can expand its support. The decisions or the optimal decision for this was to expand into the boundary which had the most number of critical loads, because one of our important priority is to make sure that the critical loads are supplied to the fullest. Our results then show that for the entire outage duration of 24 hours considered, the microgrid is able to supply the critical load to 100% and maximized the supply of non-critical load. Further, we also compare our approach against the traditional two-stage system, which consists of the day-ahead and the real-time dispatch, along with considering different forecast error scenarios. Under both the cases, we see that our proposed approach can supply critical load under different forecast error scenarios from A to F at 98% and above, while the traditional two-stage approach fails in that aspect. Further, the non-critical load supply is also consistently higher for our proposed approach as compared to the traditional two-stage approach. Our key takeaways can be summarized in this section here. And in the future work, we're still continuing to improve our approach and integrating it with a better demand response mechanism, accounting for cold load impact, as well as trying to validate the performance of our model in using hardware in loop simulations. Now, thank you very much for listening to my presentation. I hope you all found it very informative. This research wouldn't have been possible without the support of US Department of Energy and our industry partners, Wilson Energy and Stata Solar. Thank you very much.